We're building our entire AI future on these massive mountains of data. But what if the foundation is cracked? What if the data itself is flawed? That's what we're digging into today. Data integrity. It's this cryptographic bedrock that decides if we can actually trust our AI. So let's get right into it.
Okay, this quote, it just nails it, right? We never really think about storage, do we? It's just there. But it's the silent partner in every single AI model. And think about the stakes. If the data training a medical AI gets even slightly corrupted and nobody notices, well, its diagnoses could become dangerously wrong. So trust here, it isn't some fuzzy concept. It's literally the foundation of everything.
So that leads to a big question. What makes our data so fragile? I mean, we think of digital stuff as being solid, permanent. But the truth is, the way we've been managing it for decades is actually surprisingly brittle. And to really get why, we have to pull back the curtain on the old way of doing things.
And that right there, that's the core of what we're calling the AI trust problem. It all comes down to a really simple, fundamental question. How do we know our data is what we think it is?
Forever, the answer has always been about location. We think in file paths, C drive, /this, /that, or server names, or URLs. It makes sense, it's intuitive. But, and this is a big but, it's also incredibly vulnerable.
So location-based storage, it's exactly what it sounds like. We identify data based on where it is, not what it is. The library card catalog analogy is perfect here. The card tells you aisle 5, shelf 3, but it has absolutely no idea if the book on that shelf is the right one, or if someone's ripped out pages, or even swapped it with a completely different book. All it knows is the location. It trusts the shelf, not the book.
And this is where the hidden dangers creep in. Because we're only checking the location, the data itself can change, and you'd never know. That's silent modification. Or, over time, these tiny little errors can just build up, a process called data drift. And the scariest part, by the time you realize something's wrong, you might have already trained an entire AI model on that bad data, and those flaws are now baked right into its brain.
Okay, so if location is the problem, what's the solution? Well, it's a huge shift in thinking. We have to stop asking where the data is and start verifying what the data is directly. And that's the jump from the old way to the new way, from location to content.
The magic behind this is something called a cryptographic hash. The best way to think about it is like a unique digital fingerprint for your data. It's this long string of letters and numbers that's generated from the actual exact contents of a file. It's not some label you stick on the outside. It's a property that grows out of the data itself.
All right, let's make this super concrete. See this sentence? The quick brown fox jumps over the lazy dog. Okay, when we run that through a hashing algorithm, boom, we get this string of characters. That hash right there is the one and only mathematical fingerprint for that exact sentence. Now watch what happens. We're going to change just one single letter. Look at the hash now. It's not just a little different, is it? It is completely, totally, unrecognizably scrambled. This is called the avalanche effect, and it's the whole secret sauce. Any change, no matter how tiny, and the whole fingerprint just explodes. It becomes immediately obvious something's different. And this is the big payoff. If you have two different files and their hashes match, you don't hope they're the same. You don't trust they're the same. You have mathematical proof that they are bit for bit identical. All that uncertainty, it's just gone.
So let's put these two ways of thinking side by side. The old way, traditional storage, it's all about location. That means it's wide open to silent corruption, and at the end of the day, you just have to trust that everything's okay. The new way, cryptographic storage, is all about the content. That makes it tamper-evident by design. And your verification? It's not based on trust. It's based on cold, hard mathematical proof.
Okay, so having a fingerprint is great, but that fingerprint is only useful if you've got a super reliable place to keep it, right? I mean, how do you make that proof permanent and public, and this is key, not controlled by any one single company? Well, that's where things like blockchains and other decentralized networks come in. So here's what the new workflow looks like. It's pretty straightforward. 1, you create your data. 2, you generate that unique hash, that fingerprint. 3, you take that hash, and this is important, just the tiny fingerprint, not the huge data file, and you anchor it on chain. And then 4, the big data file itself can be delivered super fast from the cloud, just like normal. Sticking that hash on chain basically gives it superpowers.
Suddenly, it's publicly attestable. Anyone, anywhere can check it. It's tamper-evident because trying to change it is basically impossible. And, for me, this is the biggest one. It's independent of platform trust. You don't have to just trust your cloud provider anymore. You can prove it for yourself. So when you put all of these pieces together, you end up with something totally new, a modern data pipeline that's built from the ground up to be trustworthy. It's this really elegant two-layer system. You have a trust layer, and its only job, handled by decentralized networks, is to guarantee the integrity of those data fingerprints. And then you have a performance layer, which is just your regular old cloud infrastructure, doing what it does best, delivering data fast. And this, right here, is the key takeaway. This isn't about replacing the cloud. It's about giving it a massive upgrade. You get the absolute best of both worlds, the mathematical certainty from the trust layer and the incredible speed and scale from the performance layer. One for trust, one for speed, both working together perfectly. So I'll leave you with this question. Think about the data that's powering our world, powering the AI you use every day. Is its integrity based on a foundation of fragile trust or on verifiable proof? Because honestly, the answer to that question is going to define the entire future of AI. Thanks for watching.